Good morning, Tehmina Khan is here in TKMaths is fun. In today's video, which is video number 4 on binomial distribution, we will study deciding whether a binomial distribution is appropriate. So there are questions where scenario is given to you and then you have to comment either binomial distribution is suitable or not, reason and everything. So I have picked up here 3 questions, and in the earlier videos we have seen the following pointers you can see here, and now we are focusing on this one. The next video will be on mean and variance of binomial, and that will end the topic. All the links will be available in the description once all the videos are ready. So here are the QR codes on all the videos I have made on P1 and S1. You can scan it to learn more maths. So for this particular topic, either binomial distribution is applicable or not, you need to recall the 4 conditions in which binomial distribution is applicable. So these conditions are, I'm repeating because we will need them in the explanation. The number of trials should be fixed. It should not be infinite. Trials should be independent. Probability of success should be constant for each trial. And the outcome for each experiment is only yes or no, success or failure. So let's see 3 questions. In a bag, there are 8 green counters, 7 red counters. 2 people, Emma and Jack, take part in an experiment in which 6 counters are to be selected from the bag. Now, in Emma's situation, what it is, she is told that put the counter back into the bag. So she looked at the counter once she picked it out, and then she put it back. And every time she does the same thing. But what is Jack is supposed to do? Jack has to take the counter, see the color, and then he is not supposed to put it back. He is putting it in his pocket. So the random variable x is the number of green counters selected. You have to give a reason here why x follows a binomial distribution in Emma's experiment, but it doesn't follow binomial distribution in Jack's experiment. What is the reason? So I will show you here explanation I have written, because writing could take longer, so I have already written here. But you can tell yourself and then we will. So you are absolutely right. Out of the conditions we have seen, in case of Emma, what is happening? She is putting the counter bag into the bag. So total number of counters are not changing. And every time she draws it out, the probability of green will remain same, which is 8/15. Whereas in the Jack's experiment, what is happening? He is taking the counter and putting it in his pocket. So next time when he take it out, the probability does not remain same. The total number of counters are changing, and of course when it will be green, that will also get lesser. So that's why we can comment like this. Exactly what I've said. So trials are independent in this case, right? And every time it will be 8/15. And this is a case of with replacement. Now what is happening in Jack's experiment? Because he's putting it every time into his pocket, so the trial depends on the outcome of the preceding one, and definitely the probability will not remain the same. So it doesn't follow a binomial distribution. So this is how you will explain in your own words. Next question. Kawasi is playing a board game and he has to throw a 6 on the die in order to start. The random variable x is the number of times Kawasi throws the die until he throws a 6. Now you have to explain why it does not follow a binomial distribution. Very simple question, right? What is the reason? Yes, you are right. The number of trials are not limited. It is not fixed. It is saying until he gets. So maybe he does not get 6 in 5 throws, 10 throws, 12 throws. We don't have exact number. So that's why it doesn't follow. Since there is no limit to the number of the trials required, that's why it does not follow binomial distribution. Okay, last case. Now this is something interesting. I will talk about it. One extra thing which is not in the question, because the same question is asked in two ways. Fred takes 12 shots at a goal. Okay. You have to state any assumptions necessary for the number of goals he scored to follow a binomial distribution. So you have to give any two reasons here. So for example, you have given these reasons. For example, you are saying that scoring a goal in one shot is independent of scoring a goal in all other shots, because we know that in case of binomial, one pick or one probability of taking thing out will not affect the other one. So you are saying that this is our one assumption, that one goal will not affect the other one, or it will be independent. And the second one, you are saying the probability of scoring a goal on any shot is the same for all 12 shots. What does it mean? That Fred's ability to score a goal does not improve with practice. Now this is the point when the same question can be asked in a way that though binomial distribution is being applied, but why it is not a suitable model. Then in that case you have to answer the same question by saying that being a human factor, when Fred will score goal, his confidence level will build up, and the probability that he will score the next goal better, or with practice he will improve. So that's why it will not remain same. Are you understanding my point? Right now we are saying कि what are the two assumptions we can make. We are making some assumption here so that this situation suits to binomial distribution. But if the question is framed in other way, then you have to answer also accordingly. I hope you understood. So thank you very much for watching the video. Next video, which is video 5, will be on the mean and variance, and then it will end the binomial distribution explanation. Afterwards, we will do only questions from past paper. So if you will subscribe, you will get the indication immediately. Thank you very much for watching the video. Please press like and subscribe button and share it.